Recording in progress.
So, good morning, everyone. Can you hear my voice? Yes or no to me once. Okay. So, the last class I'm trying to conclude JVM architecture anyway. So, this is the diagram we are planning actually. Right. So, I written notes up to Java stack area. I written the notes here. Let me show that once. So, offline students who are joining online, some convenient will not be there for you because of this reason. I'll execute very less class. So, I don't want to force you. So, Monday onwards, I'll increase the level and come. So, today, let me make some review on it once, like this. So, finally, yesterday, major information I delivered to you. Right. You got complete information about first three partitions of runtime data area. So, we are under JVM architecture anyway. JVM architecture with internals. JVM stands for Java Virtual Machine and which is used to execute Java bytecode. JVM internally divided into the following partitions. Up to now, nodes are not attached. Following partitions: class loader subsystem, runtime data area, and execution engine. So 3. Now, class loader subsystem will load the class file onto runtime data area using loaders. The class loader subsystem will load the class file onto runtime data area. But this runtime data area internally divided into 5 blocks or 5 partitions, you can say. One is method area, one is heap area, one is Java stack area, one is PC register area, one is native method area. So among these 5, the class will come and load onto method area. That only diagrammatical form. The class will come and load onto method area. Objects are created in the heap area. All methods are executed in Java stack area. It's a theory. For this, whatever the program I written, demo methods 1, last 2 days, I'm drawing the diagram behind it. So demo methods 1, at last by yesterday, you got the complete information about demo methods 1. Complete information came. So what you observed here now, sir? I observed. Here, observed. Sir, whenever the object creation started, the object is created in the heap area. The object is created in the heap area. While object creation, instance members are getting the memories. Yesterday, I made one statement down. Who read the notes or who written the notes? Bit care. Offline students are writing the notes, but online we don't know whether you are writing the notes. Only online students. Whether you are writing or not, we don't know, but you have to write it. Here, I made a statement. Whenever the object has been created, developer should visualize 3 parts among object. Object different, object reference different, object reference variable different, object rent. So object means the memory generated to hold some instance members. Generated to hold some instance members. Yesterday, I drawn one visual here. If it is object, this memory part we call it as object. Means a memory, display to memory. Together one memory, we call it as object. Object represents memory or object represents storage. Now object is created at one address location. Object is created at one address location. We call it as object reference. This reference will be available on one variable. We call it as object reference variable. That's a theory. So finally, you got that information yesterday. From that diagram, you got the scope also. Means where the variables are available, where I can use it like this. You got complete information here. So class variable means available within the class, can be accessed by the methods available within the class. If a class is having any objects, the objects also can access class variables. That's the theory, class scope. Object means the variables available in the object can be accessed by the methods available in the object. Methods available in the object. That's called object scope. If any variable available in the method, inside the method, local variable, that is method scope. They can be used only inside the method, the theory. So lifetime also I given a clarity yesterday in the regular class anyway. Local variable will have least lifetime because when the method frame destroyed, local variable destroys. Next least lifetime is for instance variable. When the object destroys, instance variable destroys. Static variable is in the class level. So when all methods removed from your Java stack area, the class is deleted from method area. When the class deleted from method area, automatically class variable is destroyed. It's a theory. So this is for yesterday's class. I said I will conclude this. But instead of concluding this, because that is a new concept now, some people will be inconvenient for it. So this, what I'll do is, for 15 minutes, I'll draw the second diagram. The second diagram is a second program, demo methods 2. I'll draw it. Then I'll give the solution for demo methods 3. So this one, the solution you are waiting, this solution. With that, I'll conclude the class for today. Less class only. After that, I'll come back Monday. I'll continue the new concept. Here, I am putting execution flow of demo methods program, demo methods 2 dot Java based on execution flow of demo methods 2 dot Java on JVM. We are putting on JVM. The knowledge what you gained for 2 days, we are making a revision with one program. Already demo methods 2 is available for us. This is now. So demo methods 2 anyway. Open your edit place. Go with demo methods 2. This is demo methods 2. Very less program to load it. Here the method is with parameter and return type. Second program I typed as with parameter and return type. So we took one source code. We saved the program with, observe it, it's like a revision only, last 2 days revision with one more program. Sir, we saved with the second program as demo methods 2 dot Java. This is our source code. We are performing compilation process. We are performing. Whenever we performed compilation process, demo methods 2 dot class file will come. After compilation, dot class file will come. So this one, bytecode, we can call it as compiled code, you can say. This is compilation. So Java C demo methods 2.java. After compilation, one dot class file is coming. I am sending this dot class file for execution. I am sending for execution. So Java command for execution. Java followed by demo methods 2. Then I said in the notes, JVM has 3 parts. One part is class loader subsystem. The class loader subsystem will take this dot class file. Will take this dot class file. The class loader subsystem, the part of JVM, class loader subsystem will take this file. That only theoretical notes available in your book. Will take this file and load it onto runtime data area with the support of loaders. Some internal loaders will be there, linkers will be there, and so on. Loaders. Now, runtime data area means 5 partitions you had it. Sir, among that 5 partitions, we had complete information about first 3 partitions. We had complete information, sir. One is method area where classes are loaded. Method area where classes are loaded. Heap area where objects are created. Java stack area where methods are executed. These 3 parts part of your JVM, we had clarity till yesterday's class. So last means last 2 sessions. This is the information you had it. Method area, heap area, Java stack area. Now that class loader subsystem will take this dot class file and load it here. It loads the class here. The class is loaded here. Demo method 2. Demo methods 2. It is loading. The class is loaded here. The class loaded. You had a definition. The partition of runtime data area where the class is loaded is known as method area. You had information through last theoretical is there and you've seen the diagram also. While class loading, static members will get the memories. Demo methods 2, static members will get the memories. In the demo methods 2, how many methods available? Can anybody can type in the chat box? How many methods available? Sir, 2 methods are available. 2 methods are available. One method is MUL. One method is main. So 2 methods available. One is MUL. One is main. Among these 2 methods, one is instance method. One is static method. One is instance. One is static. Instance means non-static method. So this method, what is available here? Like int multiplication of int x comma int y. So x and y. Int multiplication of x comma y. This method is instance method, nothing but non-static method. Non-static method, memories are not available in the class. Yes or no? Instance methods, memories are not available in the class. So now multiplication MUL method will not get the memory within the class, but main will get the memory. Main will get the memory. So main got the memory. So this is your class. So demo methods 2 class loaded. MUL method, no memory in the class. Main is having the memory because main is static. That's the information. Now, once loading completed, you know, the execution engine will come here. According to the yesterday's diagram, the execution engine will come. This arrow is execution engine arrow. Imagine the execution engine will come for execution. I made a statement in the notes, who are reading the notes bit carefully. The main method will come here for execution. The main method will come here for execution. When the main method comes here for execution, separate partition is created, known as method frame. That only your notes is yesterday. We call it as method frame. So main came here. So main came for execution. We are imaginating main. Yesterday I explained this also already. The main will come here. Once the main comes here, execution starts. When the execution started, the first line is executed here. Under main, first line, int v1 is equal to 7, int v2 is equal to 2. Now these two variables are instance variables or local variables are? Instance variables or local variables? Type in the chat box. Sir, they are local variables because the non-static variables which are declared inside the methods, we call it as local variables. So v1, v2 are local variables. So local variable memories will be here. Inside the method only, local variable memories will come. That is your visual. Sir, v1, this memory, 4 bytes memory, v1 is equal to 7 and v2 is equal to 2. Like this, 2 are local variables, we had it. Once the 2 lines execution completed, then you have to create object. We are creating object for demo methods too. We are creating object for demo methods too. Here, the syntax. Demo methods too. The syntax. Demo methods to OB equal to new demo methods 2. So create object for demo methods 2. So object means one storage or memory. The objects are created in the heap area. The objects are created in the heap area. So execution engine, by seeing that line, it will understand. It has to create the object. In the process of creating object, the control will go here. The control will come here and create one address. One address is created in the heap area where one object is created. How the object is created? What are the instance members available in the class? The instance members memory should come here. So here multiplication method, the memory will come here. The multiplication method, memory will come. So int multiplication of int x comma int y, the memory will come here. So that memory, we call it as object. This memory, we call it as object. Memory generated to hold instance members. Yesterday, review I written here. The memory generated to hold instance members of class is known as object. One memory generated to hold instance members. So multiplication, MUL, is a instance method. So the memory is here. That only concept. So here memory came. Right. Once the object creation completed, the address will be loaded. The address will be loaded onto OB. OB will get the address. OB is holding the address because it is non-primitive data type variable which hold object reference. Right, this is object. All of you understood object creation? Says or no to me. Since 2 days I am trying. The memory generated in heap area to hold instance members of class is known as object. Now you have to call that method for execution. Whenever you want to call that method, you have to call with object name. That only here. Object name. So how I am calling now? OB dot multiplication I am writing here. This one I should explain. So int res here. Here. Int res. Int res is equal to OB dot multiplication of V1 comma V2. I am passing parameter. Now I am calling the method for execution. I am calling the method for execution. This method I am calling. I'm calling the method. I'm putting one arrow there. The method belongs to object I'm calling. Now the method should come out for execution. The method will come out. Multiplication method will come here. When the method comes out, one partition is created. Again, one partition is created. Separate partition. For this method, separate partition. Every method will have its own separate partition when it comes to the Java stack area, because the data must not be mixed. Now the method is coming for execution. The method is int multiplication here. Int multiplication of int x comma int y. So this is the method. The method. This line I'll keep it. This method came for execution here. So when the method came for execution here, whatever the data is available on V1, V2, what are the data available on V1, V2? They are copied onto X and Y. They are copied into X and Y. This V1 loaded here, and this V2 loaded here. So V1 loaded onto X, V2 loaded onto Y. All of you understood this? Say yes or no to me. The value on V1 loaded onto X, the value on V2 loaded onto Y. Now X and Y are holding the data. The variables which are used to transfer the data from one method to another method are known as parameters. Now V1, V2 transferring the data to X and Y. V1, V2 are known as parameters. This int X and int Y, the two are local variables to multiplication. Int X and int Y. The two are local variables. They are local variables. So X is equal to 7 and Y is equal to 2. So X and Y are the local variables to multiplication. Very careful diagram. Main is having its own local variables, V1, V2. MUL is having its own local variables, X and Y. Local variables, X and Y. So what is the calculation part available in the MUL? See that. Can you see int Z here? So int Z. So int Z means again it is a local variable. Int Z is a local variable. So Z is a local variable. The Z will get a value after calculation. Z will get the value X into Y. x into y. The value will come. Whatever the result generated by x and y available in the z, z is a local variable. So 14 will be there. Whatever the value available in the z now, 14, return z. RETURN, return z. The method is returning the value. The method is returning the value. The returned value will come back to method call. The returned value will come back to method call. From where that method came, the value will come here. All of you understood this blue line? Say yes or no to me once. Return type method. The method is returning the value after method execution. So point. Now whatever the value has been written, the value is nothing but 14. Now the value will be available on RES. The value will be loaded onto RES. The value will be available on RES because here equal to symbol is there, no assignment. Assignment operator is there. So the value will come and load onto RES. So RES also local variable only. Finally, the data available in RES. That's the concept. All of you understood this? The point. So the returned value, return statement will return the value. The value will come to the method call. So who are not understanding, read the notes. Notes is there with you. Notes will play power. Online students, you have to make notes. If 1 or 2 days, notes, sometimes the concept will run 2-3 days. The notes immediately will not come. After mixing the total concept, 3 days it is running. In that situations, you have to maintain the notes just for reading. See there. Parameters are the variables which are used to transfer the data from one method to another method. Today, x and y transferring that. V1 and V2 is transferring the data to x and y. Return type methods, non-return type methods. See there. The methods which return the value after method execution are known as return type methods. The methods which are declared with void, declared without void, are known as return type methods. We use return statement to return the value after method execution. We use one return statement to return the value after method execution. The returned value will come back to the method call. I made a statement. The returned value will come back to the method call. That only diagram. The returned value is coming back. Means whatever the z value 14 is coming back and loading onto RES. Once it came back, this method frame will be destroyed like yesterday discussion. Now the data is available on RES. When the data is available on RES, you are displaying RES. Multiplication is equal to RES. The output is coming from RES. That's the concept. So the output RES is equal to 14. That's the point. The output is coming from here. So this is the flow. All of you understood second program flow? This is the flow. I drawn only 3 blocks I drawn because 3 blocks nodes is there. Again, same information. See there. Method area where class is loaded. Heap area where object is created. Java stack area where methods are executed. The first method copied onto Java stack area is the main. Main will call the remaining methods for execution. That's the concept. So this is the second flow. So today I'll add the diagram anyway for you. This is your diagrammatical flow of second program, demo methods 2 on JVM. Right. Now I'll write the solution. So the notes I'm not giving on PC register, native method I'm not giving. So I'll come on Monday and I'll give it 15 minutes notes. I'll give it anyway. So I loaded that diagram there. I'll load this diagram. Today I'll copy the notes. 3 days notes I'll copy. Thursday, Friday, Saturday. Since 2 days I stopped the notes because yesterday only concept ended. 2 days concept yesterday only ended because notes not available. If I upload the notes also, information will not be there because we not loaded. In such cases, sometimes the concept will take 2 days, 3 days. 50% notes will never upload. So the students has tried some running notes for reading purpose. Right. Now one assignment I given before holidays. This is the assignment. How many of you done? Raise your hands. This is the assignment. Right. So I'm putting. I want to take one class as a student. The methods available known as calculate, main, and so on. So I'm taking a program, observe it. So click on file and close. Take a new file here. Click on file, new. We are going to take one Java file here. Java file we are taking and so on. One minute, stay in the line. 1 minute. Sorry. Look here. Now I am taking a class according to the question I given. Take a class name as a student, I said. Class name as a student. I asked you to take one method. Return type is float. Parameter is int. Int total marks. So take one method. Calculate. Return type of this method is float. Method is float. Parameter is int total marks. Int total marks. Here, according to this, calculate the percentage, I said. What will be the percentage? Percentage also will be in the float. Percentage is equal to total marks. Total marks divided by 600 into 100. This is the formula, no? RETURN, return percentage. Yes or no, na? Total marks divided by 600 into 100. Say yes or no, this is the formula or not? So we are taking 6 subject marks, no? We are taking 6 subject marks. So we took 600. Hope everybody knows mathematics, I think. Sir, you can strike out 0, 0 here. You can strike 0, 0 here. Then it will be divided by 6 only, no, sir. We can take divided by 6. Average of 6 subject marks. That only percentage. So total marks divided by 6 is a percentage. Just now we written Z value, now we are returning percentage. I given the program by seeing the above program only. Already I given demo methods 2. Based on demo methods 2 only, demo methods 3 will come. That's the concept. But here I took a class name as a student for demo purpose. Now, here reading from keyboard not available. I asked you to take 6 subject marks. Take 6 subject marks with values, I said. So take 6 subject marks in the main. Because I given clarity also here. In the main method, you have to take it. So I am taking 6 subject marks here. Int subject 1 is equal to 90. Int subject 2 is equal to 77. Int subject 3 is equal to some 61. Int subject 4 is equal to 89. Roughly some marks you have to take it. You are in the starting stage only, no? Some 91. Int subject 6 is equal to 93, like this. Sir, can I take in the same line? You can take, no problem. Int S1 is equal to 90, comma, S2 is equal to 77, comma, S3 is equal to 61, comma, you can take it, no problem. For visible clarity, I took like this. Now calculate the total marks. Calculate the total marks, I said. Calculate the total marks. Whenever you want to calculate the total marks here, this one. Total marks will be int only. Total marks is equal to, if not TM, total marks is equal to S1 plus S2 plus S3 plus S4 plus S5 plus S6. Total marks S1 plus S2 plus S3 plus S4 plus S5 plus S6. This is total marks. So I took 6 subject marks with values and I calculated total marks. After calculating the total marks now, I want percentage, no? Right. What I'll do now? Whenever you want to use this method, calculate method is a instance method. Whenever it is a instance method, you have to create object for student. So we are creating object for student here. So student OB equal to new student. I am creating object. So I am creating object for student class. I am creating. So why you are creating object for student class? If we create object for student class only, you can access this calculate method. You can access this calculate method. You can access. If we create object for student class, you can access. So call it OB dot calculate pass total marks. Just now I passed your V1, V2. Now I am passing total marks. Now the calculate method will take the total marks and calculates the percentage and return the percentage. Whenever it returns the percentage, catch that percentage here. Percentage is float. PR you take roughly result PR. You are loading on to PR roughly. Just now I drawn the diagram where it is returning the Z value. Here it is returning the percentage. If you observe clearly, now I drawn one diagram demo methods to this program, both are same concept only. Only difference, their multiplication of two values, here average of 6 marks. That only calculation difference. By seeing that similarity only I given the question. Whether you will grasp, whether the student will get a idea by seeing the above program or not, that is the assignment. Who done it very good? You got an idea by seeing above. Who not understood, you have to revise yourself once. Because above program you not analyzed properly. Hope. Or you not concentrated. The two reasons will be there. Same concept only here. Now the result will come and available on PR. Then display it. You can display total marks, you can display percentage. Both you can display. Whatever you want. But I not given any print specification, I not given in this question. Your wish. If you want to display only percentage, you can display. Here I given display percentage. If not, you want to display total marks and percentage, you can display. So I am displaying total marks and percentage. So system.out.println, I am displaying the total marks. Total marks I am displaying. I am displaying the total marks. So system.out.println, I am displaying the percentage. That is PR. So now save the program with the student. Click on file. Save. Under demo 51, you save it as student.java. Student.java. Save it. Run the program. Go to the folder D drive, demo 151, open command prompt CMD and compile the program. Java C student.java, run the program. Java student, the answer will come. Total marks 501, percentage 83.0. Sir, 83.0, correct answer, sir. Check it. Go with the calculator program. Sorry, not program. Open calculator. 501 divided by 6. Where is this? 1 minute. 501 divided by 6. What is the answer there? 83.0 na 83.5 ah? Can you see my calculator there? Sir, it is 83.5. But 83.5 did not came, no, sir, here. Sir, why it did not came, sir? Means, look here. In Java, here, total marks is integer. 6 is integer. Integer divided by integer, actually here, quotient only will come. Output is quotient. Output will be quotient part will come. Output is quotient. So output will be one quotient part only will come. Quotient part only will come. No, sir, I want complete part. Whenever you want complete part, convert into float. The result should be converted into float. Then calculated value will come. Divided by will give quotient actually. If I convert it, calculated value will come. Now see the result back. Recompile the program and run it. Now see the answer difference. All of you observe the answer difference. First output you observed, say yes or no to me. In the first case, 83.0, second one 80 part not generated. In the second part, fraction part generated. So in Java, whenever you want to have a calculated value with fraction part, if two integers are there, total marks integer, 6 integer, here calculated part will not come. Only quotient part will come. I want calculated, total calculated value means convert into float. These notes will come, don't worry. The point. Right. All of you understood this program, says or no to me once. Right. This program and the last 2 days notes, everything will be copied into the drive. Google Drive is there, no? Google Drive, because many people not joined your Google Classroom. I'll copy the 3 days notes, Thursday, Friday, Saturday, today, 3 days notes at a time into Google Drive and Google Classroom. Both I'll copy it. In both location, I'll copy it. The program is student.java. Student.java. Yeah. So this is the answer you had it. So this is and I'll add these total notes, 3 days notes into Drive and Google Classroom. Who are in the Google Classroom, you can see there. Who are in the old Drive is there now for you. The Drive is there. And finally, assignment for today is nothing but draw execution flow of above program, means friend.java using JVM. You have to draw the diagram. Above program, diagram you have to draw your own. All of you understood today's class? Say or no to me once. One flow, one program, that's all. New concept on Monday. New concept means conclusion. This conclusion I'll do it on Monday to you. This conclusion I'll do it on Monday. PC register area, native method, execution engine. It takes 20 minutes. After conclusion, I'll go with the next continuation. So Monday onwards, disturbances will not be there. Because of these holidays, we had a huge disturbance. And our course also slowed down because of this disturbance. So Monday onwards, non-stoppingly, we are going to go. Right. Take a break bit early. I'll upload the notes now within 10-15 minutes in both. Take a break.